Hey, good morning, guys. I'm going to make a couple videos this morning, reviewing a couple different properties that have to do with chords and secant lines inside certain tangents that meet inside and on circles. Um, you don't really need to absolutely know why these things are true, but I would be doing my due diligence as a teacher if I didn't show you why they're true. So this one we did in class, but I'll make another video going over it. I'm gonna make 3 separate videos as opposed to putting them all together. Hopefully that'll encourage you guys to watch them. They'll be a little bit shorter. So essentially, if you have 2 chords intersecting inside a circle, you have the segments AE, EB, CE, and EB. And the rule says, the theorem says, AE times EB is equal to CD times ED. So in order to show why this happens, the first thing we need to do is we need to make ourselves a couple of triangles. Now I know everybody hates triangle proofs, but they do have their use, guys. And I'm not going to write a formal proof just because I know that will immediately make you guys stop watching. Okay, so we have 2 triangles, and the first thing we need to do is we need to show that these triangles are proportional. So I don't know if you guys remember. Hopefully you guys remember. That essentially what we need is we need to prove to show that these 2 triangles are similar. We need to prove that the angles are the same. And in fact, we said we didn't even need to know that. We actually just need to know that 2 of them are the same. So I'll show you why all 3 of them are the same. But here's the thing. So if we had angle A, and I can call it angle A because it's just by itself. Okay, there's no other angles here. Okay, angle A intercepts arc CB. Right, so we see that angle A intercepts arc CB. So angle A is equal to 1/2 arc CB. And we learned that last week. But we also know that angle D also intercepts the same arc. So if angle A is half of arc CB, and angle D is arc CB, then we know that angle A and angle D have to be the same. Okay? We can say the same thing for angle C. Angle C is equal to 1/2 of arc AD. We know that angle B is equal to 1/2 of AD. Right, so here we go. Angle B is 1/2 of AD as well. And we also know that angle AED is congruent to angle, let's call it angle DEB. And we know that because they are vertical angles. So AEC. AEC and DEB, we know these are congruent because they are vertical angles. So I'm going to draw a single line there and a double line here. So we know that these 2 triangles are congruent. Important, let's keep them in a nice order. So we'll say the triangle A has got one line, E has got a line and a stripe, and C is similar to, right, triangle DEB. And make sure if you're going to label these things that they are nice and neat and organized. We do know that AE is to CE, right? So this side is to this side, and make sure in your other triangle you're taking these in the correct order, as DE, right? DE is in the same position as AE, if you guys remember that, is to what do I say? BE, EB, BE. Now I wrote them in a little bit different order. It doesn't really matter. But the big thing is that you keep them in the correct order. So this side between the angle A and E and C, right, is the same as D and E and E and B, or B and E, however you feel to write them. But this side is to this side, as this side is to this side. Okay. And then simply, guys, you guys should know this by now. If you guys are in two-hour proportion, you want to solve it, you can cross multiply. So we say AE times BE is equal to CE times DE. And all we need to do to show that this is true is just write them in a little bit of different order. Remember, it doesn't matter really how we label these chords. So AE is to EB, right? Just switch the letters around. And CE is to EB. Okay. So again, what does it really come down to? And it's going to be the same thing for the other two proofs as well. So essentially, we're going to make ourselves some triangles. We're going to prove that they are similar, and once we're similar, we're going to set the little proportion. So if before you get to the other two videos, if you want to give them a try and see if you can figure it out yourself, it would be a really good exercise for you guys to undertake if you guys are starting to get these concepts, okay? So again, like I said, I'll make 2 more videos and I'll post them. Thanks.